this question is also talking about gases leaving a container, so we're looking at Graham's law. But since this one mentions time, I'm going to want to use the formula that has time in it, which is different from the others because the ones are going to be straight across from the ones and the twos straight across from the twos, not diagonal. In unknown gas, we're looking for its molecular weight. So one of my molecular weights has to be an X. I'm going to put that on top because I think it makes the algebra easier. An unknown gas leaves the container in half the time of SO3. SO3's molecular weight will go in the bottom. So this is unknown. This is SO3. 32 plus 3 times 16 is going to give me 8. Now, that means unknown's time should be on top and SO3's time should be on bottom. But they don't give us any times. They just give us this fraction 1/2. So, the unknown gas leaves the container in half the time. The unknown gas has less time. I'm going to say that the known gas moves it in 1, whether it's second, minute, whatever, because 1 is something I know how to take half of. The unknown gas in half the time. So half of 1 should be the unknown gas's time. 1/2 should be on top, or 0.5 if that's easier for you to type in your calculator. You could have made up any number you wanted for SO3's time, as long as for the unknown's time, you used half of that number. So if I wanted to put 100 here, put 50 there. If I put 2 here, I'd put 1 there. I just need to make sure that the unknown gas is half the time of the known. In terms of solving this, 0.5 divided by 1 is just 0.5. But I want that x alone. The square root and the 80 are both in my way. The first thing I have to get rid of is the square root. So we undo that by squaring both sides. 0.5 squared gets us 0.25. The squaring here just removes the square root. Then, putting over 1 and cross multiplying, x is going to be 80 times 0.25, which is 20. That's my molecular weight. The units for molecular weight are grams per mole.